चालू करायचं. Okay, now this is the problem. U is equal to 2x plus 3y and phi equal to 3x minus 2y. These two functions are given here, and then we have to prove this derivative is equal to 13 by 4. So let us try to solve this. Now the first question has two partial derivatives. First is dou y by dou v when x is constant. We read it like this: when x is constant, partial derivative of y with respect to phi we have to find out. Now to do this, what we exactly need here is, out of all the given equations, we need y in terms of phi and x. Is it possible to convert any of this equation into this type? Tell me. Y as a function of phi and x. First of all, find out any equation is there which contains all these three variables. Is it there? This one. See, here we have phi, x and y, but instead what we need is y as a function of x and phi. So we can rearrange. I'll say this as equation number 1 and I'll say this as equation number 2. So by rearranging equation 2, we can get so what we will do, we'll bring this 2y on this side and phi on another side. So I will get 2y is equal to 3x minus phi, isn't it? Therefore y will become what? 3 by 2 x minus phi by 2, isn't it? 2 I have divided throughout and we got this one. Now the y is function of x and phi here, so we can find out this derivative. So let us apply the derivative, partial derivative of y with respect to phi when x is constant. So this is equal to, as x is constant, the derivative of first term will be what? 0. Derivative of constant is 0. So this is the first term will be 0. Then minus 1/2 is constant and derivative of phi will be what? 1. So the answer for this will be what? Minus 1/2. Okay, so this is the first term of this first question. The second term here is what? Partial derivative of phi with respect to y when u is constant. Now can you tell me how can I get phi as a function of y and u? Is it there? We have any equation which contains phi, y and u?
No.
Is it there? No. We have uxy, pxy. So what we have to do, by using these two equations, we have to do something such that we will get a function of phi in terms of y and u. That means x is not present. We don't need x here. So if I try to eliminate x from both of these equations, we'll certainly get equation of phi in terms of y and u. Can you tell me how can we eliminate this x term here?
Substitute in x.
Exactly. These are just simultaneous equations. So by multiplication, substitution is also one of the method, but if you know well, you can also do by the solving of the simultaneous equation. The LCM of these two terms here, we have 2x here and we have 3x here, and its LCM is how much? 6. So we can multiply 3 throughout this equation and we can multiply 2 throughout this equation. So what can we write? Equation number 1 into what? 3. And then we have to what we have to do? We have to subtract equation number 2 into 2. This way also we can get it. So let us do this. Equation number 1, we have to multiply 3 here. So I will get 3u is equal to 3 into 2 is what? 6x plus 3 into 3 is what? 9y. And for this equation we have to multiply 2 here. So it is 2 times v is equal to 2 into 3 is 6x, and then 2 into 2 is minus 4y. And for subtraction we have to change the signs. This will be minus, and this will be plus. So these two terms will get cancelled, and here I will get 3u minus 2v is equal to 9 plus 4 is what? 9 plus 4 is 13y. Now we need phi in terms of y and u. So what we'll do, we'll take this 2v on another side. So 2v will be equal to 3u minus 13y, isn't it? I've taken this term on this side and this term on that side. And then we'll divide 2. So we will get phi is equal to 3 by 2 times u minus 13 by 2 times y. Then by taking the partial derivative as required, partial derivative of phi with respect to y when u is constant is equal to, as you know, the u is constant, so this whole term will be constant and its derivative will be 0. Minus 13 by 2 is constant and derivative of y is 1, so its answer will be minus 13 by 2. And as said in the problem, we can say LHS is equal to, LHS is nothing but product of these two. So let us multiply these two answers. So it is equal to dou v by dou y by dou v when x is constant is minus 1/2 into dou v by dou y when u is constant is minus 13 by 2. Now in multiplication, minus minus becomes plus and this will become 13 upon 4. Okay, so this is what they have asked. So we can say this is equal to RHS and we can say hence it is what? 4. Okay, so the second question here again you can see we need dou u by dou x when y is constant. For second question we need dou u by dou x when y is constant, and to find out this I need u as a function of x and y, which is already present there. So what we'll do, directly we'll take the derivative of this first equation and therefore we will get dou u by dou x when y is constant is equal to, see here derivative is with respect to x, so 2 is constant and derivative of x is 1. Then when I take derivative of this 3y, y is constant, so this whole term is constant and it is 0 and this is equal to 2. Likewise the second term we needed in this question is dou x by dou u when v is constant. Here again you can see we need x as a function of u and v. As a function of u and v. So to get this, what I need is I need x in terms of u and v. Can you tell me how to get this equation, x as a function of u and v? How can I get this? Can you tell me?
माइनस कर देंगे भी.
Exactly, we can eliminate y here, no? If I eliminate y here, the remaining terms only will be only u, v and x. And to do this, what we will do, again we'll multiply the LCM, which is again 6. See, 3 here and 2 here, so it is 6. So what we will do, equation number 1 into what? 2 plus equation number 2 into what? 3. We are adding this because it is already a minus sign, plus and minus sign, so it will be easy to get it cancelled. So by multiplying 2 to this first equation, we will get 2u is equal to 4x plus 6y, and by multiplying 3 to this equation, we will get 3v is equal to 9x minus 6y. And by adding these two, you can see here these two gets cancelled and this will be 2u plus 3v is equal to 9 and 4 is what? 13x. And by rearranging this in terms of x, we will get x is equal to 2 by 13u plus 3 by 13v. And then by taking the derivative, that is dou x by dou u when phi is constant, see here the derivative is with respect to u, so it will be 2 by 13, derivative of u is 1. As phi is constant here, you can check here that this whole term will be constant and its derivative will be 0 and the answer will be what? 2 by 13. And from the given equation, if we check the LHS left hand side, it is the product of these two terms which already we have found out here. So the first term is 2 and second term is 2 by 13, and its answer is what? 4 by 13. Okay, and this is equal to what? RHS. We can write hence true. So this was the third question actually. So here you can check that it is the product of first term and second term together, and the product is equal to 1. We have to show this, and as you can see that for the first term, that means for this set of terms we got 13 upon 4, and for this set of terms we get 4 upon 13. So if I put it together and multiply, 4 will get cancelled, 13 will get cancelled, and we'll get 1. Okay, so this way also question might be there in the exam. So this is second question of the same category. Here we have x is equal to cos theta upon u, y equal to sin theta upon u. Then we have to find out answer for this partial derivatives. Now one by one we'll find out all these four terms, and then we'll do the solution. So the first derivative here, the first derivative is like dou x by dou u when theta is constant. So here we need a function of x in terms of u and theta, which already exists here. So we have to apply dou by dou x to this whole equation. So dou by dou u to this equation. So we will get, see, we are taking derivative of this. So it is dou x by dou u when theta is constant. So here you can see that the derivative is with respect to u and theta is constant. As theta is constant, cos theta is also constant. So cos theta we can take it outside, and then we can do the derivative, that is dou by dou u of 1 upon u. Isn't it? Cos theta I have taken outside because it is constant, and derivative of 1 upon u is what? Cos theta into, what is this? Minus 1 upon u square. So we got the first partial derivative term. Then for the second, I'll write here, the second term is like partial derivative of u with respect to x. So we need to find out this second term, that is dou u by dou x when y is constant. So I need a function of u in terms of x and y. So do we have this here anywhere? Can you tell me? Do we have u in terms of x and y here? No, no. So how can we get u as a function of x and y from this? Yeah, we can substitute, or we can eliminate theta.
Theta sine
So to eliminate theta, can you tell me some idea here?
square.
Exactly, square and add, है ना? Sin square plus cos square is 1, na? So what we'll do, I'll say here this as equation number 1, this as equation number 2, and while what we will do is we will square and add together equation 1 and 2. If I do so, the left hand sides will be x square and y square. So I will directly write x square plus y square on left hand side, and right hand side will be what? Cos square theta upon u plus sin square theta upon u square. So if I take 1 upon u square outside, inside the bracket I will get cos square theta plus sin square theta, which is equal to what?
1.
This is equal to 1. So definitely I got here x square plus y square is equal to 1 upon u square. But what I need is u in terms of x and y. So we will again rearrange this. I'll take this u square on this side, and then u square will be what? 1 upon x square plus y square, and u will be what? 1 upon root of x square plus y square. Then here we need partial derivative of u with respect to x when y is constant. So to do that, we'll apply this partial derivative on both sides of this equation. Left hand side will be like this, right hand will be, see, this is what? This is the function of x and y. As x is there inside this square root, what we have to do, we have to do the derivative of this whole thing. So it is like derivative of 1 upon root x. Do you know what is the derivative of 1 upon 1 upon root x?
minus 1 upon x to the power 3 by 2.
Is it so?
Minus 1 by 2 into 1 upon under x to the
Yes.
power 3 by 2.
Yes. So what we'll do, we'll rewrite this as x square plus y square raised to minus 1 half. Is it okay? And then we'll take the derivative of this by using the formula n x raised to n minus 1. So n is our minus 1 half. So minus 1 half into x square plus y square bracket raised to minus 1 half minus 1. What is it?
3 by 2.
Minus 3 by 2. Okay, as many of the things get cancelled in the latter stage, so it is better to keep it as it is. Okay, so for now we will keep this as it is and let us see what happens. Then this was the second term, this term. Now let us find out the next term, that is the third term is, what is it, dou y by dou u, right? Dou y by dou u when theta is constant. So what I need is y in terms of u and theta. So this one already exists here. So directly we will take the derivative. So this is equal to, see, derivative of y with respect to u, and theta is constant. As theta is constant, sin theta is also constant. I am taking it outside. And derivative of 1 upon u is what? Minus 1 upon u square. Okay, so this can also be written as minus sin theta upon u square. Okay, so this was the third partial derivative, and then we need the last one, that is what? Fourth one, that is partial derivative of u with respect to y when x is constant. Now here I need u as a function of y and x. Is it available there? Can you tell me? U as a function of x and y?
No.
No? We already prepared one like this, no? So it is already existing here. So let us take this equation and do this partial derivative. So this will become, for this equation, dou u by dou y when x is constant, it is equal to, this is,
Minus 1
we'll take this one. So it is again minus 1 half x square plus y square raised to minus 3 by 2. Sorry, I have missed here something. The derivative of inside term is missing here. So the derivative of inside term will be what? With respect to x. X square ka derivative of x square is what? 2x. Derivative of y square will be what? 0. And for this case, derivative of y square will be what? 2y. And derivative of x square will be 0. So we got all these four terms. So we'll keep these two terms together and we will get this LHS is equal to this term. First term is what? Minus cos theta upon u square, first term. Then second term is right here and it is what? Minus x square plus y square raised to minus 3 by 2 divided by 2x. So 2 gets cancelled here and we need only x term here. Okay, x term here. This is the product. Then plus this third term is here, this minus sin theta upon u square, and the fourth term is right here. 2 gets cancelled here and it will be minus y times x square plus y square bracket raised to minus 3 by 2. Isn't it? So this one we can simplify here. So as you can see, so we have kept all these partial derivative terms on this left hand side, and now let us simplify this. So what we can do, either we can bring all the terms in x and y, or we can bring all the terms in theta and u. So it is better to convert this into x. As you can see, it is cos theta upon u square. So out of that, for cos theta upon u, we can substitute x. So this will be minus what is it, cos theta upon u is x divided by u, and this is what, now I will write plus here, minus into minus is plus, then inside this bracket I have x, and divided by, I'll write this as x square plus y square bracket raised to 3 by 2. Now here for this I can write plus, again minus minus will be plus, sin theta upon u is y, you can check it here, so it is y upon u, and here I will have y upon x square plus y square bracket raised to 3 by 2. Then I'll multiply this, and as the denominator is similar, what I'll do is I'll add these two terms, so it is x into x is x square, y into y is y square divided by u times, this is basically x square plus y square into root of x square plus y square. Can you see this? Raised to 3 by 2 is 1 and half.
Yes.
So this is power 1 and this is power 1 half. So these bracket can get cancelled with this one, and I'll get only this. And here you can check u is equal to 1 upon root of x square plus y square. So this is nothing but 1 upon u into 1 upon root of x square plus y square. But this is nothing but u. So if I substitute this, I will get 1 upon u into, for this term I can write u. Then u get cancelled, and finally I'll get 1 as answer. So answer for this whole partial derivative is equal to 1. Thank you.